right, this is Unit 8.1, Lesson 9 for contact forces. This is Day 3 investigations. So, our standard apply scientific ideas and evidence to construct an explanation for the causes of motion and kinetic energy changes that happen before and after collisions and how these affect the outcome of a collision. We're going to respectfully provide and receive critique about claims to identify relevant evidence to support an explanation for how energy transfers through the cart launch system before and after a collision. We're going to develop and revise a model to identify other parts of the system that the cart and the box are making contact with or colliding into are producing contact forces on these subsystems, which are causing energy to be transferred to or from them as the box and the cart travel down the track. By the end of this lesson, students should be able to explain how contact forces such as friction and air resistance cause energy transfers within a system and should be able to analyze the results of their experiment on how different speeds, masses affect the amount of damage caused in the collision by drawing conclusions about contact forces and energy transfer. You should be able to explain how contact forces like friction and air resistance affect the motion and energy transfer, identify independent and dependent variables in an experiment, conduct an investigation to observe the effects of speed and mass on a collision, and analyze data collected from experiments to identify patterns and draw conclusions, and construct scientific explanations based on evidence gathered during experiments. Remember our classroom norms. We're going to be respectful. We're going to be equitable. Everyone participates. All ideas are valuable. We're going to be committed to our community. We're going to learn by doing together those discussions and those other pieces. And we're going to move our science thinking forward. We're going to start to figure things out together. So thinking back on the previous lesson, I want you to look at the video and then answer the bell ringer question. So let's do the video first. So in this investigation, you see there's nothing in the cart. And you see that as it was launched, it started from 0 centimeters and it's going to end up at 10.2 centimeters. So you saw that the spring-launched cart made contact with the box. It pushed the box forward. Changing the mass or speed of the cart affected how far the box was pushed. Even though the cart was applying a force to the box when it was in contact with it, the box and cart always eventually come to a stop. So do you think changing the shape of the box or the cart would affect how far they traveled before coming to a stop? Pause the video to add your answer. All right, so we're going to watch the second video. This time we're going to watch a cart that has a sail and one without a sail. We're going to record our observations here. Let's play the video. She's launching the cart. There is nothing. It's just plain cart. Now she has a sail attached. And now she's got a fan. Again, no sail. And then with a sail. So what did you observe? This is from the wind blowing behind. All right, record your observations on your slide. Pause the video. All right, so on this slide, we're going to look at our cart launcher system. This is a model based on the 4 parts that we've consistently used. We've got the launcher, we've got that cart, we've got the box, and the track that the cart runs on. So we can see that at 0 seconds, nothing's been going. After 1 second, you can see there's some energy forces or some motion you can see after the cart. After 2 seconds, 3 seconds, 4 seconds, 5 seconds. So this is for a 5-second model. But think about how the other contact forces like friction and air resistance are causing energy to be transferred between the moving parts of the system. What's missing? We have our motion that's showing the cart going forward. We see the boxes moving. What's not being represented on this? Think about the answer. We'll pause to discuss. All right, for the next activity, we're going to look at the 3 sets of data. We have graphs. We're going to look at this. We're going to record observations about what you're seeing. So in data card 1, we have the speed of the headwind. Remember, headwind is coming from the front. And the kinetic energy loss. In 2, we see the speed, miles per hour. This is the direction, the wind direction, and how it affects the fuel consumption on cars. And then there's your fuel consumption. The third one is average miles per gallon by vehicle type. We have a refuse truck, which is AKA a garbage truck, a school bus, a van, a car, and a motorcycle. And then we have the miles per gallon. So what do you notice? What do you wonder? Record your observations on the slide. Pause the video to add your answers. On the next slide, we're going to launch the simulation. We're going to press play. We're going to let it run for several seconds, and then we're going to look at the questions. So while you're watching, think about the question: how does the motion of objects and the particles that make up those objects change? You can also reset and rewatch the simulation if you need it, recording any additional observations. So let's press play. I enlarged the simulation. Down here, you can press play, and you can see as the box goes across the rough surface, you can see what's happening. So we can we can change the surface. What do you notice? What do you wonder? Here's the video again. Reset. What do you notice? What do you wonder? After you finish with your observations about what happens to the particles of the 2 objects, if you've reset, you can add any additional observations here. On this slide, we want to do the exit ticket, add in those other contact forces like friction and air resistance. How is that causing energy to be transferred out between a moving object and the other parts of the system? So what have we figured out? Use your source of evidence. Where did you find it? What investigations, videos, etc.? And then in your own words, what did you figure out? If you would like to use words, or if you'd like to use pictures, you can also draw. For instance, the cart and the box launcher model we had earlier. You can also add in any new drawings to represent anything like the force of friction or air resistance and where that energy is going. Then, of course, at the end, assess your learning. Which one of these can you do? What do you still need help with? And remember, as always, we are a work in progress. We are continuing to work on mastery so that we can be successful.